Hello guys, welcome back to new video, and today we'll be solving a Leetcode September daily challenge question. So the question for today's challenge is good count good nodes in binary tree, which is a medium level question. And let's read out the question first, and then we try to understand our problem approach, and then we will try to code it down. So what our question says that we have given a binary tree root. A node x in the binary tree is named good if in the path from root to x there are no nodes with a value greater than x. Okay, we have to return the number of good nodes in the binary tree. So we have given a binary tree. So this is our example one. We will try to understand uh, what it states. In the example, you can see that there is a navy blue color node and one is a white node. The node which is a navy blue color, it is a good node. So let's move on. So we have to find a number of good nodes. So what is a good node? A good node is a node uh, which is always greater than or equals to the nodes present from a root to that particular node. Okay, in this case our 3 is a root node. Okay, when we traverse to its left hand side, we reach to 1. We observe that 1 is not a good node. Why it is so? We observe that 1 is not greater than or equals to what you can say a 3. Hence, 1 is not a good node. When we again travel to left of 1, we reach to our leaf node, which is 3, and we see that 3 is a good node. Why is it so? It is because uh, when we travel from root and reach to 3, there is no node which is greater than or equals to, which is greater than uh, mm, what you can say 3, although a node can be smaller than or equals to 3. So hence 3 is a good node. You can see uh, that root is what you can say equals to our current node, but it is not greater than 3. So let's see the approach. I'll make this a full screen. So what we will do is we will maintain a global variable count, which will be our answer. Okay, so we will be traversing our what you can say uh, binary tree. I mean, we will take a pre-order traversal. So when we will start from our root node, which is 3. Then we will check if 3 is whether 3 is greater than our maxine. uh, okay, we will maintain another variable which we will call it as a maxine. Okay, and we will check if our current node is greater than or I mean is less than is greater than or equals to our maxi. If it is so, we will increment the count. Okay, so first of all, we will observe that 3 is equals to our what I can say a maxime. So we will increment our counter from 0 to 1. Okay, then we will move to its left. We observe that 1. Okay, so then we move to when we reach to 1, then we again move to our left hand side. Okay, just ignore this is your 1. Okay, I'll make it in proper fashion. Okay, hold on. So yes, you can observe that we had reached to 1 over here. Okay, then we move to the left of 1, and we see that 3 we reach to 3, and we see that 3 is equals to our maxine, which is our root node 3. So we will update our maxine as 3 and we will increment our count to 2. Okay, next. Then we will move to the left. We observe that there is a null. So we return. Again, we move to right. We observe null. We will return. Again, we will go to 1 and we observe that we will go to the right. We will observe null value. We will return. Again, we will return from this and we will reach to our root node. Now we will traverse through our right hand side. When we reach to 4, we observe that 4 is greater than or equals to our maxine. So we will update our maxine to 4. Our new maxine now will become 4. Okay, I know this might be sounding bit confusing, but please stay on for up till last. I guarantee you that you will understand this question when I'll code it down. So our new maxim becomes 4 since it is greater than or equals to our previous maxim. Okay, okay. So also we will update our count. Now our count will become from 2 to it will become 3. Okay. Now again we will traverse to left hand side. We observe that one is less than our maxim. So we move to left. We return since there is null value. Again we move to right. Here it is null value. We will return. Then we will go to return from node 1 and reach to 4, and then we will go to the right hand side of the uh, 4 and we reach to 5. We observe that 5 is greater than maxine and we will update our count to, or we will increment our count to 4 and we will update our maxine variables to 5. Okay, and similarly we will move to left hand side, observe null. We'll route to right hand side, observe null. Since finally once we get this count, we will return this count to the user. So as per our approach, we will declare here as a global variable count. Okay. Then here we will create a function name as good nodes. What you can say, recur. So we have created that function. We pass root and our again root dot val, okay, to this function, and here we will return count. Okay, so let's make our what you can say, right? Hold on. Now I guess this might be visible to you. So good node. This is our base condition. Okay. Then this is our condition, which means root dot val जो है, अगर it is, if it is greater than or equals to max scene, so what we will do, will update max scene variables to root dot val, and we will increment our counter variable. Okay, so we have done up till now. Now we will call recursively this function for left and right respectively. Okay, max c root dot left, we will copy this down over here, control c, control v, and yes, is not left, it is right, RIGHT, right. So now hopefully our code must run. We will recur, recur. There might be, I'm sure there might be some spelling mistakes. So let's keep what you can say, note of spelling mistake as well. Sometimes it usually used to happen that we used to spell that particular function wrong. So another one, mistakes. So cannot find good notes recur. Good notes recur. Just let's run that text, our test example, and then let's submit. I hope our question, yes. So that's it for today's video. So happy coding, keep coding. Bye bye. See you tomorrow in the next video. And if you haven't liked, please like, and please subscribe to my channel. Till then,